today actually involves two parts. The first section, if you remember, on last Friday, we did just a little bit of section 3.1. We're going to finish that section up today and then tie it into section 3.2 because it's talking about the same kind of angle pairs. The first section really gives you the definition of what these angle pairs are, and then we're going to look at parallel lines and those specific angles to come up with some theorems for the second part of the lesson. But we need to talk about what a transversal is and then these different angle pairs that you can create when you have two lines and a transversal. Here's your notes, or is the vocabulary. A transversal is a line that intersects two coplanar lines at two different points. So you can see this picture. I know it's kind of shaded in the middle there. It has angles 3, 4, 5, 6. But you've got a pair of lines. They don't have to be parallel. They can be very slanted or almost looking parallel. But a pair of lines and then another line that intersects both of them at different points, that is the transversal. When you make that arrangement, you end up with 8 angles. And if you want your notes to match up correctly, it just goes left to right, angle 1, 2, 3, 4, 5, 6, 7, 8. Down. When we talk about interior or exterior in relation to these definitions, interior means when you look at those two lines, it's the space that is between those two lines. Okay, so the space between the two lines is the interior part of this picture. Outside of that is the exterior part of the diagram. So let's see what our terminology is. Okay. Out of those 8 angles, angles 1 and 5 are an example of corresponding angles. 1 and 5. Another example would be 2 and 6. Another example would be 3 and 7. Another would be 4 and 8. So how do we describe those pairs as far as where they are in this picture? Notice that every time 1 is exterior, 5 is interior, 3 is interior, 7 is exterior. It's always matching up 1 interior and 1 exterior. Here's the way they describe it. These are called corresponding angles. They're on the same side of the transversal, on the same sides of lines R and S. Same sides meaning like above line R, above line S, or below. So 1 is to the left of the transversal and above line R. So its corresponding one is to the left of the transversal and above line S. 4 and 8, for instance, to the right of the transversal and below line R. To the right of the transversal and below line S. So they're in matching places at each intersection. Question to clarify?
I'd like 1 and 3 and 5 and 7
1 and 3, no, because those are, remember, a linear pair of angles. And we want 1 angle at this intersection and 1 angle at the other intersection. Okay? So since 1 and 3 are both at the same 2 lines that cross, no, that's not a pair of corresponding. It's a good clarifying question. Any other things? Corresponding seems to be the one that we get stuck on after a while. We forget what those are. So they're in like the matching position on the same side of the transversal. Another pair that's in this diagram are called alternate interior angles. These are non-adjacent, okay, so they're not side by side. They lie on opposite sides of the transversal. Since it's opposite sides, that's where alternate comes from in the name of what these are called. Opposite sides of the transversal between the lines R and S because they have to be interior. So the interior angles are just the 3, 4, 5, 6. If I pick 3 that's on the left side of the transversal, then at this intersection do I want 5 or 6? I want it on the other side of the transversal, so it would be 6. 3 and 6 are alternate interior angles. 4 and 5 are alternate interior angles. What I use a lot is if you trace these angles, you make a Z of some kind. That one's kind of a stretched out looking Z. If I go with angles 4 and 5, that's a Z backwards. So when I say it forms a Z, that's the alternate interior angle idea. The corresponding angles, because they're not hooked together, they really don't make any certain letter. All right, third one down, alternate exterior angles. Exterior now, and alternate would mean different sides of transversal. So if I pick angle 1, is it 7 or 8 that would go with it? 8. So 1 and 8 are alternate exterior, 2 and 7 are alternate exterior. And then the last one is same side interior angles. So if you're catching on to what it means, same side of what? The transversal. So either in this picture on the left side of the transversal or the right side, and interior angles. So just the ones in the shaded region. So if I pick angle 3, which one is a same side interior angle with it? 5. So 3 and 5 pair together, 4 and 6 pair together. So there's 4 different types of pairings that we are going to be working on. Let's try a different diagram and see if you can come up with those. All right, why don't we pair up this week? Instead of front and back, let's go side to side. So these 2 rows pair up, and let's see. I guess that works in the back. Let's go these 2, and then we'll do the odd here. So I guess that's pairing the way we did last week. Whatever. Okay, discuss these with your partner.
Okay. Corresponding would be.
Why don't you write all
Like-
pairs? It says give an example, give all examples. So make all the pair of corresponding angles. Be sure you're discussing it with your assignment partner and you're just adding it.
Yeah.
Yes. The 4 pair of corresponding angles. Because it limits you to just interior or exterior. No, they would be actually 4. 4 would be corresponding. Actually, 1 is 4. could you come up with? There should be 4 pairs. How many alternate interior angles? Pairs. Should be 2. Alternate exterior angle pairs? 2. Alternate same side interior angle pairs? 2. Because you're only limited, or because you are limited to interior and exterior, there's not as many choices on those. Okay, corresponding, for instance, 1 and 3, 2 and 4, so on. Alternate interior, one of them should have been 2 and 7, then 3 and 6. 1 and 8 for alternate exterior, also 4 and 5. And then 2 and 3 or 6 and 7. I just listed 1, I changed the directions on you to list all of them. Okay, so that was with your partner. Let's see if you can do it without your partner. Question?
Would it matter if you had like 2 and 3, 3 and 2?
No. No, you're just listing which ones they are. The order doesn't matter. Okay, so I turned the diagram, re-scrambled the numbers. On your own now. Figure out. It just says give an example. We'll just go with one. We'll discuss all of them, but if you have one, follow the directions. Some of you are good about putting the angle symbol because that's what we learned. Others are not. Okay, give me a pair of corresponding angles. Shay? 1 and 5 are corresponding. That's what I had. Some other pairs would be, H. 2 and 6, yes. Brendan? 4 and 8, and I think there's one more pair. Caleb? 3 and 7, correct. Okay, alternate interior angles would be what, Molly?
Angle 3 and angle
3 and 5, yes. And then also, Abby?
5. Angle 4 and angle 6.
4 and 6, very well. Okay, alternate exterior, Zach?
2 and
2 and 8, correct. I had 1 and 7. And then same side interior angles. Let's go with Michael.
4 and 5.
4 and 5, yes. And the other pair, June? 3 and 6. Yes, that's one. Okay. If there are more lines, and I guess if they're tipped more, it maybe looks a little bit more complicated. How do you like this picture? Now on this one, you might say there are no corresponding angles. Yes, there are, because any of the lines in this picture could be the transversal. A transversal just intersects 2 other lines at different points. So, for instance, line L intersects line N right here and intersects line M right here. You could have L as the transversal. You could have N as the transversal, intersecting the other 2. Okay? What I like to do is cover up the part where the other 2 lines cross, because that gets confusing to me. If I can block out that part, then it's easier for me to see there's my pair of lines and transversal. So what these problems are asking is which line is the transversal, and then are they corresponding alternate interior, or what are they? So let's look at angles 1 and 3. I'm going to put a dot. Angle 1 I'm interested in, and angle 3. Okay, now which line is the transversal to create those two angles? Well, it is the one that connects their vertices. Here's the vertex of angle 1. Here's the vertex of angle 3. The line that connects both of them would be the transversal. So line L is your transversal. And then classify each pair. I don't know if I can block out this part of the picture. Okay, I don't want to see anything except the part that makes angle 1 and 3. How do I get it to block out? I need a black one or something. Okay, so imagine this is gone. Does that help? Maybe like that. Okay, now can you pick out the pair of lines in transversal? Are 1 and 3 corresponding angles? Are they alternate interior, alternate exterior, or same side interior? Okay. Can you pick out corresponding? They are in the matching position, so they were corresponding. All right, so let's get rid of those dots. Now we want to look at angle 2 and 6. You write down on your board, with angle 2 and 6, figure out which parts you want to block out. Try and cover it for you. What kind of angles are they? It blocks it out well on the back side of my cardboard. Which line's the transversal? Nathan? Which one's the transversal? N is the transversal, correct. What kind of angles are they? Kenny? Okay. Alternate what? Are they between the pair of lines or not? Our pair of lines would be this one, right? There's this line and this line. Are my dotted ones between those lines or not? Yes, they are. So they're interior. And I would agree with you, they're on different sides of the transversal, so those were alternate interior angles. Transversal was N. Question helping you see that? Okay, how about 4 and 6? Get rid of those dots. And put dots on angle 4 and angle 6. Which part is the transversal? And then in your mind, cover up part of the picture. I don't know if my cardboard's helping a lot. What part of the picture would you cover up? Yeah, cover up this part because you don't need that at all for the two that we're interested in. Which line's the transversal, Dalton? M is the transversal, okay? So decide if they're on the same side or different sides of the transversal. And then are they between the pair of lines or outside of the pair of lines? What type are they, Riley?
Alternate exterior.
They are. Transversal is M and they're alternate exteriors. So that type of a diagram is harder when you've got them crossing. But block out part of it and I think you'll do better at that. Okay, now obviously the pair of lines that we were using were not parallel. So we're going to take a look at these kinds of angles with parallel lines. And here's where we're going to try an activity on your iPad with GeoGebra. So bring up the GeoGebra app. Rather than you draw the complete diagram, I found if you search the GeoGebra materials, when it first comes up, it gives you a chance to search or to make something of your own. If you search the GeoGebra materials, even this is what it was called, parallel lines conjectures. search part. Search GeoGebra materials. Parallel lines conjecture. It should be a person named Fred Schmitz that made this one. For me, it was the top left when I was looking at it yesterday. That has the diagram that I was going to have you make. There automatically. It's got some directions on top of it. So if you will click on like the text part, that measuring an angle kind of thing, and then the double arrow icon. It has the arrow up and down like the XY axis. On that icon, you can pick hide label, I think it was. I did that to get the words out of the way. You could delete it, but I just did the hide it. So click it and then do the hide label. Sure, hide label. Off to the left is the pointer.
This isn't.
Somebody said you just deleted it. You have to activate it first. Oh, darn it, it's not doing it exactly the same. All right, can you get it out of the way? So did my directions not work for you? No? Okay. You could select it, you could go to the show hide, but you had to do it in the other order maybe. So maybe you had to go to the double arrow thing and pick the show hide and then pick the text. Show hide. That still didn't work. It worked when I did it, darn it. Okay. All right, you did get it to work? Excellent. All right, so just drag and get them out of the way. Okay, what I want you to do, what they have set up is they have created parallel lines. If you will go back to the pointer that's on the left, that arrow icon's up at the top, the one on the left, if you select that, that's the pointer so that you can pick anything you want. I think he set it up with point B. If you would grab then point B, or touch it, and move it, does the whole diagram move for you?
The two parallel.
The parallel lines do, maybe not the transversal. Okay. So you can see that the lines were created parallel. Now, in a lot of our diagrams so far, we weren't doing parallels. Okay, what I want you to do, let's see if we can get this to work. Measure the corresponding angles. Like pick out one pair of corresponding angles in your picture to measure. Now the angle icon up at the top, you should see one that has kind of the angle, maybe it has A in there. Up at the top. Okay, if you pick that, you are able to select an angle. Now, if you read your directions down at the bottom, it's telling you to select the points. Okay, what I found is you have to select the 3 points in a counterclockwise direction. Otherwise, it goes a long way around. And if it does the wrong one, just undo it and hit the points again. So on your picture, I don't know where your A, B, C and that are. But if I'm trying to measure this angle over here, I'm going to hit this point, then hit that first, then this one, and then this one. That would be counterclockwise, and it should measure that angle. And then try and measure its corresponding angle also. And if you need a stylus, I have some over here. Anyone need a stylus to help you out? Anyone want a stylus?
Ooh, I'll take one.
I would like you to leave them here so we can use them again. It might look better. It might work better than. This wording would be nice if it's out there. Where's this arrow? Are we getting some measurements?
98 and 82.
Let's do like one pair of corresponding to make sure you got it. Okay, got one pair of corresponding angles measured? Yeah, and depending upon how your lines are, the angles, they highlighted them in green. The actual degree measure might be a little close. You can pick that arrow, the move arrow way to the left, that icon. If you go back to that, you can grab those measurements and slide them, move them around. So if you need to select it with the pointer and move it, you have to get it to the pointer. Now you should be able to look at it. If you want to move the actual numbers. Figuring out how to operate this? So if you want to grab something and move it, you have to remember to go back to the arrow pointer, like on the left. You have to get that activated in order to move something. And on this kind of a diagram, because of how it's set up, you cannot move every point wherever you want it to, because it was established that those lines have to stay parallel. So some points depend upon other points. So I think once we mess with it, what the B is kind of darker, you might not be able to move the light labeled points, but you can move the dark labeled points, I think. Okay, what are you finding out about your corresponding angle measures? They're the same. Did you change the diagram around after you measured that pair? That's what's nice about this kind of a program is you can experiment by automatically making a little different picture. So after you measured, if you have not gone back to the pointer icon and selected point B and did some dragging with point B, you're really looking at just one situation. If you drag point B so that your parallels turn, you should get some different angle measurements. But they still are remaining the same. Okay. That is a postulate that we will have called the corresponding angle postulate. It says when the lines are parallel, the corresponding angles are congruent. So all of what we're experimenting with is when the lines are parallel. Okay, before we look at all our theorems, let's check a few more things. Okay, you've got those angles. Let's measure one that would be an alternate interior angle. So if you, wherever your interior one is, now measure the angle that would be its alternate interior angle. Think about going counterclockwise as you specify the points. So I would try and get this one measured. Point, vertex point. If you can get an alternate interior angle in your diagram. I think you probably can. What you need to do right now. Yeah, you probably can. I wasn't worried about that right now. Okay, are we getting some alternate interiors? Okay, so probably what order? Can you just point to me what order you're going? That would be, this one is more.
That's really changed the clockwise.
Very much DC. Okay, alternate interior angles, what relationship? They should be the same. Now, and we could prove that because of the vertical angle involved. Okay, let's measure, let's see, one more angle. I could do this alternate exterior angle. So measure this angle, which would be alternate exterior with the one you had at the beginning. Measure that one. What would you expect? It should be the same. Are you figuring out how to tell it to measure angles so it really does the one that you want and not the reverse of it? Have to think counterclockwise as you're going through that, and that's hard for me to remember. And if your numbers are getting bunched up, select that pointer tool and touch the measurements and slide them out a bit. Okay, then I have not measured same side interior angles. Okay, so on my picture here, I'm gonna go from this brown one, same side interior, so I'm gonna try and measure this, in my picture, obtuse. So get one of those so that you have a pair of same side interior angles. And was that the same also? You get it to measure the right spot? Is it working? Are you not doing it, Paul? Oh, we're having fun and you are dead. Okay, are you finding that that same side interior angle is different? Okay, so what relationship do we have there? Let's see, let me fill in some numbers. If this was 70, and this one was 70, and this one was 70, and this one was 70. But now that I did a same side interior, it was 110. So if I actually look at the same side interior angles, they're not congruent, they are supplementary. And again, pick your point B and slide your diagram around so that you see more than one example. Remember, we can't come up with a conjecture unless we have more than one to look at. But I guess we've got about 20 some in the room. All right, so what relationships will we have? When the lines are parallel, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. If the lines are not parallel, those relationships are not true. And you can't really get them not to be parallel on that picture because that's how it was set up to be parallel. Okay? All right, we're going to need to go back to our notes. So you'll have to just flip your iPad over or shut it off. That was our experimenting. And you can, anytime you want to, you can go to that GeoGebra and play around with it. It's kind of fun. You could try and see if you could build that diagram. Can you get the parallels in transversal? I just thought it'd be easier if we pulled it up. Okay, so here's to our notes, and we'll do some example problems along the way. The hypothesis is that there are parallel lines cut by a transversal. I'm going to be using that same picture for all of them. So if you're putting it in picture form, you might draw it on this first one and then kind of arrow that it's down, down, down. But also make a note that the hypothesis you have to have two parallel lines. So in the diagram, make sure you are highlighting these are parallel. Got to have parallel lines. So the corresponding angles are congruent. So notice there's a lot of possible conclusions. We could conclude angle 1 congruent to 3, 2 to 4, 5 to 7, 6 to 8. Not just that they are corresponding, but they are actually congruent. I have a few examples before the other theorems, but we'll use that same picture for the hypothesis and the others. Okay, done with that? Before we hit the other theorems, here's a diagram. So what would be the measure of angle ECF? 70 degrees, because the corresponding angle and the lines are parallel. So 70 degrees, corresponding angle postulate would support it. How about angle DCE? DCE, this angle. Now, if I only looked at the one we were given and the one I'm looking for, notice they're not corresponding. They're not alternate interior or alternate exterior or same side interior. So we can't go directly from that 70 to that angle based on a theorem or postulate. Use the 70 that we just found. And how is the angle that we're looking for related to this 70? They're supplementary because of? What was that theorem that said those would be? Linear pair theorem, I heard somebody say. Yes. Okay. So they were supplementary by the linear pair theorem. So you will have to use some things that we have studied previously. Okay, this one's more algebra. Find the measure of angle DCE. So we're supposed to come up with this in the end. So look at what else there. You do have parallel lines. Yeah, work it out and show me an answer at the end. How would you find angle DCE? How would you find X? Angle DCE all by itself is not a hundred. There's 5x and 4x plus 22. Those are corresponding angles.
Equal to each other. So you just do 4x plus 22 equals 5x. Yeah, but how'd you do that?
Okay, on this one, you need to be setting your two angles equal to each other because of the corresponding angle postulate. These are the corresponding angles. Our theorem our postulate that we're just working on now is when the lines are parallel, those corresponding angles are congruent, which means they're equal in measure. So don't add them to be 180, no. You set them equal to each other. Then solve and substitute in, the final answer should have been, it was 110 degrees. Questions related to that one? Okay, let's try another one. I think Okay, find angle QRS. The directions angle QRS. That's this angle. I know we haven't done those other theorems yet, but you can use just the corresponding angle postulate. The 118 corresponds to the x, so x is 118 degrees. Then what's the relationship between the x and the angle we want? Those two form a linear pair, so they are supplements. So 180 minus 118. 62 degrees for the angle that we're after. Question on that one? Okay. If the transversal is perpendicular, you're going to create a lot of 90-degree angles. This one would be 90. Linear pair is 90, vertical is 90, linear pair is 90, corresponding angle, 90, 90, 90, 90. So on those, just be aware you have 8 right angles when it's perpendicular. Okay, we did the other exploring while we had our iPads out. So your alternate interior angles, again, when the lines are parallel is your hypothesis. If you just arrowed and copied that same hypothesis from the first one, your conclusion here, the alternate interior angles are congruent. So angle 1 and 7 will be congruent, 3 and 6 will be congruent. The next one is alternate exterior angle. It's almost going to look the same, so if you're not watching, you won't notice that it changes. Ready? Change to exterior. Okay, so now it's angles 1 and 8 that would be congruent, 4 and 5 that would be congruent. Same hypothesis, you have to have parallel lines cut by a transversal. The last one is the same side interior angles. Okay, let's watch and see how that changes. Those are supplementary, they're not congruent. So the last one, your pairs of same side interior angles are supplementary. You might emphasize that one's different. It supplements instead of congruent. But I think it's kind of nice. The supplements are the same side interior angles. S. Same side interiors are supplements. All right, so we'll try and mix them together here and do a few more examples. All right, so watch for which pair they are. This one's just simply some degree measurements. Tell me which angle you can figure out and support it. Tell me an angle and how many degrees. We can do this one together. Shape. Reason for that one being 118? Corresponding angle postulate. Okay. Next student. Sam, haven't heard from you. Which angles? I was going to say 2 is already 118. Angle 3 is, did you say 62? Why? He could probably give me one of 2 reasons. Looks like he wants some help. What's his reason, Abby?
Well, the same side interior angles.
Okay, he could do, I'm gonna scribble out the 3 and 2 so they don't look like big numbers. He could use the same side interior angles being supplements. What's another reason he could have used? Okay, going back to a previous chapter, linear pair theorem could be used. Okay. All right, give me another one. Hey, John,
Angle 7 is also
why?
corresponding angle possible.
Okay, corresponds to that one, or linear pair here. Yes. Angle 1, is that what you're telling me? I'm not quite hearing what you're saying. Okay, Kenneth,
Angle 4 is
118, why?
180.
Alternate interior angles, yes. Or he could have done linear pair, or he could have done vertical angles. Okay, so Paige, that would help you. Vertical angles, angle 1 could be 62 degrees, or angle 1 could be supported alternate exterior angles. See, there's a variety of ways you could go through. Okay, Jaden, give me either 5 or 6. Because alternate interior, so she's going there. And 6, Brianna? Why? Alternate exterior. Okay, and there could be other reasons. All right. Now let's see if we can do something with variables. We're going to find x, and then for the second step, find some angles. Okay? There's more than one way you can find x in this problem. So I'm giving you a variety of things to think about. Find a way to find x. And know what your support is, like why you can do that. Looks like the majority of you are using the corresponding angles. I don't know if that's what I did. No, I did something different. Oops. So the way that most of you are going, you're going 2x minus 135 equals x minus 30. Corresponding angle postulate. This angle has to be the very same as this one. What's x when you solve it?
105.
105. Okay, question getting there? I'm not seeing any head shakes. Okay, so now find the angles. ABF. ABF, what is this angle out here? X was 105, so I think maybe I'll fill in. This is 105. What's 105 minus 30? 75. And this one must be 75 also because it's a same side interior or a corresponding. So the angle ABF that I'm after, 105, either based on linear pair or corresponding angles. solved it a different way. And how about angle FBC? Support for that, Brendan? Alternate exterior angles, okay. Could have done vertical, could have done linear pair. All right, thumbs up or down? Make sense out of that one? All right, I caught a few of you setting up your equation incorrectly at the beginning of that one. Now, I did a different equation. I used these two and added to B180 because those were same side interior angles. So that was just another way. You could have done these two added to 180 because of a linear pair theorem, something we previously talked about. All right, and I think this will be our final one. Find the measure of angle ABD, but before you do that, you have to find what X is. Are the lines parallel? Are those angles corresponding, alternate interior, alternate exterior, or are they the same side interior, so we need to watch for? And if they're not any of those, then we need to think about some other things to do. Once you find X, substitute in, see what those angles are. Probably will help you answer the question. Now this solving, you should have X to be 25. And the angle you're after was 60 degrees. That's looking pretty good. All right, I just had some if we had time to check. So you're focusing on those angles. The first page that your assignment involves is just naming them. Are they corresponding, alternate interior, or whatever? And not too many on that page. Page 158 is when the lines are parallel. Now are they congruent or are they supplementary or whatever? And we have not too many. Radicals quiz tomorrow. I'll be good next time. To cover me. Wishful thinking. Now, just to clarify on these first ones, remember you don't have to have the lines parallel in order to have things that are corresponding and alternate interior. Angle 1 and angle 2 are corresponding angles. They're definitely not congruent. When do you have the congruent situation? When the lines are parallel. They have to be parallel to get those congruent or supplementary relationships. All right, you can mess with GeoGebra a little bit. See if you can do something. And yeah, I want my stylus back. For another class. Okay, registration. Stop my recording.